One of the three major components of arithmetic is numbers. You're familiar with numbers. Use them every day whenever you use money or look at the time. But each number can be categorized based on what rules apply to it and what form it's in. It's best to make sense of that now. In math, the concept of categorizing something is a set, and a set is a clearly determined collection. Sets can be completely arbitrary. As long as you have a clearly determined collection, then you have a set. In this case, you close them with these curly brackets, and if you put a value in there, such as 1, that's a set. It's the set of the number 1. And you can put multiple values in by separating them with a comma, and then you could put more values in. But this set doesn't mean anything. The sets that I'm going to show you are all of the real numbers that we'll use in arithmetic. This is going to be an overview of sets. Videos later on will show how each set can be built up from previous ideas, and you'll get more comfortable working with each set as we go along. The first set of numbers is the natural numbers, and is shown by this symbol n. Think of when you count. It starts at 1, continues to increase 1 by 1, so to 2, then to 3, 4, and so on. You can count forever. So the natural numbers is an endless set. We represent that you can keep on counting with the 3 dots. What's next in line? Well, you can see that you're going up by 1 each time, so you know that you just continue to go up by 1. While we start counting at 1, there is a state of nothingness, and in math, we call that 0. The set of 0, along with all of the natural numbers, so 1, 2, 3, 4, and onwards, that's the whole numbers. It's represented with this sort of W with the extra brackets. In the set of whole numbers, counting up leads to higher and higher numbers. But what about counting down? When you reach 0, do you stop? You would stop if you were just counting the whole numbers, but you can actually keep counting down, in which case you find the negatives. Negatives are a category, so you can consider them a set on their own, but typically they're included with all of the whole numbers to make the set of integers, and we represent that with a z. Integers come from counting up and counting down, which is just addition and subtraction. But there's also multiplication and division. Division specifically is useful to show how the next set of numbers form. Suppose you divide 6 by 2. Well, that equals 3, which is a whole number. But what if you divide 5 by 2? That's equal to 2.5, which is here, somewhere between 2 and 3. It can't be called a whole number, so it's called a rational number because it's represented by a ratio. The rational number is a set represented by a q with the little lines in it. It can be anything described as an integer divided by another integer. So that includes all of the whole numbers, such as 6 over 2 equaling 3, and all of the negatives, but everything in between as well. And there is a lot of rational numbers in between all of the whole numbers and integers. So far, this is what we have. We have the natural numbers, we have the whole numbers, which contain all of the natural numbers and 0. We have the integers, which is all of the negatives and all of the whole numbers. And we have the rational numbers, which is all of the ratios, including all of the integers. But just like plus and minus and times and divide, there are more complicated operations. Divisions caused the rationals, and the operation of roots cause another set. This is the set of irrationals. Not every root ends up irrational, such as the root of 4. That ends up as 2, which is, in fact, all the way up to a natural number. However, the root of 2 can't be represented by any kind of fraction. Pi is another irrational number, the root of 5. All of the irrational numbers, and there are quite a few, are in a separate category, in a separate set from the rational numbers. So you have irrationals and you have rationals. All of this together, the irrationals and the rationals all make a large encompassing set. This is the set of real numbers. These aren't necessarily every number in existence, but among them all are consistent rules for arithmetic. There's a story here that the numbers can tell. They're the actors, while the operations are the setting, and the properties that we'll soon learn about are the rules. Working with numbers will cause you to become more familiar with them. At some point, you'll just understand them. Something will click. Now that you know what categories they belong to, you'll start to make sense of why and how to use the operations in math problems.